the integral from negative infinity to positive infinity of x e to the negative x squared dx. All right, Nick, do you have any initial thoughts on this problem?
I split it up in zeros. So
Okay. All right, so this is a really good idea. We noticed that it's improper because we have infinities, and not only that, but we have infinities on both the top and the bottom. So a good place to split it is somewhere in the middle. We might as well go 0. So negative infinity up to 0 of x e to the minus x squared dx, plus the integral from 0 to positive infinity of x e to the minus x squared dx. Okay? All right, so we now have just one improperness on each of these. And so my next step is going to be to evaluate each of these integrals separately. Nick, which one would you like to look at first? This one here? Okay, so let's analyze the left one first. So we've got the integral from negative infinity up to 0 of x e to the minus x squared dx. And we want to make this proper. So in order to make this proper, we can put b in for a big number. B up to 0 of x e to the minus x squared dx. And we'll take our limit as b approaches negative infinity. Okay. So now I've got this expression. If I ignore the limit in front, we have a proper integral. And now we need to ask ourselves, how are we going to evaluate, or how are we going to find the antiderivative of x e to the minus x squared?
Use substitution.
Yeah, u substitution seems like a really good idea. If we allow u to be negative x squared, the power, then our derivative is going to cancel that extra x. And so life is going to be good for us. So du over dx is equal to negative 2x, telling us that dx is equal to du over negative 2x. So we've got the limit as b approaches negative infinity of the integral of, well, the x's are going to cancel. We're going to have a negative 1/2, and we're going to have an e to the u du. So you should double check that all that stuff cancels. And we still need to fix our boundaries. So when x is equal to b, then u is equal to negative b squared. And when x is equal to 0, then u is equal to negative 0 squared, which is 0. So our top boundary actually stays exactly the same. Okay, any questions about changing the boundaries or changing our integrand to all in terms of u's? Okay, so now I can take my antiderivative, and I've got the limit as b approaches negative infinity. And I've got negative 1/2 e to the u evaluated between negative b squared and 0. And I can plug in my boundaries. Limit as b goes to negative infinity of negative 1/2 e to the 0 minus a negative 1/2, so that becomes plus 1/2 e to the minus b squared. All right. I've plugged in my boundaries. I'm going to try and clean this up a little bit. E to the 0 is just 1, and so this first part becomes just negative 1/2. So I've got the limit as b approaches negative infinity of negative 1/2 plus 1/2 e to the minus b squared. Okay, any questions or comments about this part?
I didn't change my boundaries out, but I still got this answer. I just plugged in my B and my X, and it still came out.
So the two options, one option is to change the boundaries to U boundaries. The other option is to analyze this as an indefinite integral. Get your indefinite integral, turn it back into x's, and then plug in your x boundaries.
That's right.
That's fine as well. Absolutely. Good. Other questions or comments? Okay, so the next thing that I want to think about here is what's going to happen to the e to the minus b squared. That's the main part that we're interested in. Now, to analyze my limits, it's often a good idea to get rid of negatives in the powers. So I might rewrite this as the limit as b approaches negative infinity of negative 1/2 plus 1/2 times 1 over e raised to the b squared. Okay, so thinking about this expression, the negative 1/2 remains exactly as it is. The 1/2 times is fine. The part I'm worried about is the 1 over e to the b squared. So let's think about b. b is getting really large in the negative direction. So b squared, as b gets really large in the negative direction, b squared,
0.
well, b squared itself is also going to get really large. So b squared is going off to infinity. Now, is that positive or negative infinity?
Positive.
Good. Then why positive?
It's too negative, or when you square a negative, it becomes one.
That's right. Even though the b values that we're looking at are negative, we're squaring that. And so in the end, b squared becomes a positive large number. Okay, so we have 1 over e raised to a really, really large number. E raised to a really large number, what's going to happen to that term? Yeah, that's going to get huge, right? E to the b squared is going to get really stinking huge. And so if we have 1 divided by something really stinking huge, what happens to that? It's going to get tiny. It's going to go to 0. If you have 1 pizza and you want to divide it among 1,000,000 people, your slice is not going to be very large. So what that tells us is that this 1 over e to the b squared term goes to 0. And so what we're left with is that our limit as b goes to negative infinity of negative 1/2 plus 1/2 times 1 over e to the b squared, the 1 over e to the b squared goes to 0. 0 times 1/2 is 0. And so we're left with just negative 1/2. All right. Nick, does that look good to you so far? Great. Okay, are there other questions about this one? Okay, so in one sense, this is exciting because we actually got a number, but in the other sense, it's a little bit sad because now we have to evaluate this other one. If we had gotten diverge here, then we'd be done. So now we want to analyze the other side.
It's the same thing, though, isn't it? It's just the opposite.
And it should be really similar. We're going to look at the integral from 0 to infinity of x e to the negative x squared dx. And so just like the last one, we're going to have a u substitution. U is negative x squared, du over dx is negative 2x, and so our dx is du over negative 2x. I still need to fix my boundaries, so we'll have the limit as b approaches positive infinity of the integral from 0 to b of x e to the minus x squared dx. We can make our substitutions. The same substitution is going to happen as last time, negative 1/2 e to the u du. My boundaries, when x is equal to 0, then u is also equal to 0. And when x is equal to b, then u is equal to negative b squared. So our two boundaries look like 0 and negative b squared. Exact same integral that we looked at last time. The boundaries are flip-flop from before, but otherwise the same. Which means that I can actually use the same work that I have up here already.
It's just turned around though.
That's right, we've got to turn it around, so we'll take this guy and our antiderivative is negative 1/2 e to the u, evaluated between 0 and negative b squared. So we'll plug in those boundaries in the opposite order that we did last time. So we've got negative 1/2 e to the minus b squared plus 1/2 e to the 0. And just like we analyzed last time, this e to the minus b squared, I can think of that as 1 over e to the b squared. And as b gets really big, my denominator is getting stinking huge. So 1 over that denominator is going to go to 0. And so I'm left with 0 plus 1/2, which gives me a positive 1/2. Okay, so now we've got our first integral is negative 1/2. Our second integral converges to positive 1/2. And so in the end, our final value is 0, which is an awful lot of work to get a 0. All right, are there any questions about this integral? Our conclusion would be that this integral converges to 0, which we're sad about, having done all that work to get a 0. All right, Nick, does that answer your question?
Yeah.
All right. Questions or comments about this? Yes,
One more time, could you explain how you got to the positive infinity with b squared?
This one here?
Yeah, please.
So this was happening when b was approaching negative infinity.
Right.
But remember that this square is squaring. So what's your favorite large negative number?
Large negative
Mhm.
number, negative a million.
Negative 1,000,000. If I take negative 1,000,000 and I square it, it's going to be positive. And so that's what's happening here. Okay, other questions about this improper integral? Okay. Are there other practice problem questions anybody wants to talk about?
I have a question on spinel. Is this